Today's video is sponsored by Squarespace. In the depths of the ocean, going alone is rarely an option. The harsh environments of this seemingly infinite void are an imposing challenge for any lone organism to face. The dark conceals many dangers, while dazzling lights deceive unwitting prey. For this reason, animals in the ocean tend not to spread out. Instead, wherever possible, they come together in their masses to create abundant patches of life in the lonely depths. Hotspots of biodiversity, in stark contrast with the otherwise barren stretch of darkness. Safety in numbers is a foolproof survival strategy that increases their chances of finding food, evading predation, or having reproductive success in the endless blue. From vibrant coral gardens and scavenger communities to expansive blooms that cloud the ocean surface, these are the animal aggregations of the oceans. From zooplankton to top predators, aggregations are an incredibly common phenomenon in the pelagic zone, due to the challenges of living here. Strong winds, towering waves, and vast empty regions of low prey availability mean animals can either adapt to life as solitary migrators, with streamlined bodies and powerful tails for covering large distances in search of food, or they can gather together and find sanctuary in huddled congregations of life. They can migrate or aggregate. Creatures that chose the former option, like the ones we discussed in the previous video, often need to journey for thousands of miles each year between breeding and feeding grounds. But for some creatures, this simply isn't an option. Many open ocean drifters come together not of their own accord, but due to the movement of currents gathering them into biodiverse swarms of life. Beneath the waves, current-induced blooms of jellyfish get swept together by colliding currents. Here, they coincide with a rich supply of plankton, on which they gorge themselves until the entire food source is depleted. What follows is a mass die-off in the jellyfish swarms, and another remarkable phenomenon takes place. Their corpses begin to sink en masse, triggering a major nutrient cycling event that provides abundant nutrition to benthic communities on the sea floor. These jellyfish blooms demonstrate how animal aggregations that form rapidly can sometimes strip one region of its nutrients, and in death, export them to another. The coordinated behavior of fish takes pelagic aggregations one step further. Rather than being a product of currents, it is the behavioral adaptations of fish that leads to them forming two kinds of aggregation: shoals and schools. In a shoal, they swim together loosely and without much organisation. But in a school, the movements of fish become mesmerising. Shimmering, turning, contracting and expanding in unison. Hundreds or thousands of individual sardines move together as if performing a well-rehearsed ballet. A seemingly choreographed display of dramatic flourishes, made possible by their incredible ability to coordinate their body positions and synchronize their movements, all in the name of survival. Remarkably, there's no leader. These schools demonstrate a phenomenon called self-organizing, in which each fish maintains a zone of repulsion with their neighbors. The dance works as each fish only needs to coordinate with individuals nearby, creating a wave-like movement made up of thousands of individual movements. The effectiveness of schooling behavior is demonstrated by these lanternfish. The display visually confuses predators like the voracious Humboldt squid, making it harder to single out any individual fish and giving them a better chance of survival than going it alone. But although there may be safety in numbers, the mass swarming of pelagic prey also serves to draw predators out from the depths with the promise of a meal. Every night, aggregations of zooplankton rising from the depths triggers the largest marine gathering of all. A host of vertical migrators amass near the surface. From opportunistic cephalopods to filter-feeding behemoths like the megamouth shark, all drawn from the twilight zone by the prospect of a plankton platter. Among them are krill, gathering in swarms of up to 60,000 individuals per cubic meter. In total, 5 billion metric tons of marine organisms take part in this nightly migration, and unwittingly play a very important part in supplying deeper waters with nutrients. As these migrators descend once more as the sun rises, they defecate, releasing organic material in the form of large fecal pellets that sink quite rapidly. By defecating at depth rather than the surface, the pellets make it to the bottom much faster, and the efficiency of this nutrient transfer is increased. Benthic animals confined to life near the bottom cannot participate in this migration. They instead rely on the pellets. So, just like jellyfalls, the vertical migration ends up nourishing the benthos and allowing life to thrive at the very bottom of the ocean. Down in the depths of this hidden world, these creatures of the seafloor form aggregations of their own. Decaying corpses and the fecal pellets of vertical migrators settle on the sea floor. It's not much, only a small proportion makes it all the way to the bottom, but it's vital for the animals that live here. Groups of scavengers looking for a meal arrive very quickly, forming carrion communities on the abyssal plain. Ravenous hagfish strip the flesh of larger meals, while sea cucumbers sift through the sediments to feed on smaller particles. But where these carrion communities are most prolific are around regions of abundant material, like whale falls. A sunken whale carcass provides the benthos with a sudden concentrated source of food, which animals make sure to take advantage of. Drawn by the scent of death, crustacean hordes like these pink amphipods amass to feast on the whale's flesh. Some organisms have become wholly reliant on whale falls for survival, like bone-eating osedax worms, which burrow down into the whale's skeleton and feed on the enclosed lipids. Unlike the open ocean where fish aggregate for protection, carrion communities assemble to share a meal. It's not just mobile scavengers that aggregate on the sea floor. Sessile animals, meaning those that are fixed in one place, tend to settle together in far-reaching communities. Crinoids cling to any solid surface they can find, where they feed by filtering sinking organic material out of the water. Aggregations of thousands of mother octopuses tuck themselves away in crevices at the base of a seamount to lay their eggs, attracted by warm seeps in the sea floor. Cold water corals are responsible for creating one of the largest of all deep-sea aggregations. Expansive coral gardens, forming hotspots of life on continental shelves and slopes. And the upwelling zones of monumental ocean seamounts, where they are bathed in nutrient-rich currents. Seamounts are of significant importance to all kinds of marine life, for they are one of the only locations where sea-floor aggregations collide with open ocean swarms. The concentrated upwelling of nutrients that rise from the ocean floor fuels productive hotspots for both sessile communities and migratory fishes. Even pelagic wanderers that tend to go it alone are drawn here, unable to resist the abundant food. In fact, seamounts are common feeding grounds for solitary sharks and migrating whales, who emerge out of the endless blue to feed. Returning to the sea floor, corals are just one example of the deep sea's many reef builders. Alongside sponges and mussels, they belong to a collection of crucial sessile organisms that provide food and shelter, and bring structure and complexity to the otherwise featureless abyssal plain. Sponges form their own aggregations, called the sponge grounds. Here, a high diversity of symbiotic life can be found inhabiting the intricate structures of these pale deep-sea sponges. Nourished by the nutrients the stalked sponges pull out of the water column and bring to the sea floor. Squat lobsters, sponge-dwelling shrimps, and crabs, all seeking refuge from predators. This larger deep-sea crab carries a sponge in its dorsal legs as a crude form of camouflage, while granting the sponge access to nutrient-enriched currents. This relationship highlights another way that coming together increases an animal's chances of survival. By forming communities, animals can develop symbiotic associations with one another, and can adapt in ways that would not be possible without the presence of their symbiont. These Ophiocreus brittle stars form a close association with cold water corals. The corals provide a perch that grants the brittle stars access to faster, more nutrient-rich currents. In return, the brittle stars may prevent parasites from damaging the coral, an excellent example of non-obligate symbiosis, meaning both species can survive without the relationship, but coming together allows them to thrive rather than just survive. We've discussed the symbiotic associations of chemosynthetic bacteria with deep-sea organisms many times in this series, but not yet considered how this influences the formation of aggregations. Around hydrothermal vents, the presence of these bacteria converting dissolved chemicals into nutrients creates a diverse and abundant assortment of life. This is a zone of primary production, where instead of sunlight, it's chemicals that are used to form organic materials. Thus, we find some of the most peculiar of all aggregations. Tube worms cluster in the sediments. Mussel beds of epifaunal bivalves encrust the rocks, building an extensive reef on which many other organisms rely, like these predatory crabs. This goes to show that regions of productivity are especially important when it comes to the formation of aggregations. Aggregations are a vital feature of marine ecosystems, arising in areas of productivity, stability, or high nutrient density. The large-scale assembly of animals creates dynamic patches of life. Here, increased survival rates directly influence biodiversity in both the midwater and for the benthos. For although these aggregations are physically isolated, the action of open ocean aggregations directly nourishes those on the sea floor. It is a prime example of how a behavioural adaptation can be a powerful tool for survival. So, whether it be for protection from predators, foraging or scavenging, sticking together is a crucial strategy for an incredible array of marine species. Today's video is sponsored by Squarespace. Squarespace gives people a powerful and beautiful online platform to help create your own website. You can connect with your audience and generate revenue through gated members-only content. You can also send email communications, manage members, and leverage audience insights, all in one easy-to-use platform. Go to squarespace.com for a free trial. And when you're ready to launch your site, go to squarespace.com/naturalworldfacts to save 10% off your first purchase of a website or domain.